Alright, this is example 5 from the Introduction to Derivatives by Definition. This is a rational function. So I'm going to do the last two examples from the notes, one being rational and one being square roots. So let's take a look. The derivative, and I have the definition up there written for you in case you forgot, is the limit as h approaches 0 of f of x plus h minus f of x over h. So we're going to plug in x plus h wherever there's an x. So that's 1 over x plus h minus f of x, which is 1 over x, and then all over h. And so we need to somehow simplify this once again, because if we do direct substitution, we'll get 0 over 0. So we notice there's a common denominator of x and x plus h. So we're going to use that to take this entire quantity to multiply by those two factors, x plus h and x. And we'll do that to the top and to the bottom of that fraction. And what happens when we do that? Well, I'm going to show you over here and then I'll rewrite it below. So if we take x plus h, this whole thing times that one over there, alright, that'll leave us with x plus h times x over the denominator of x plus h. So you're going to see that factor cancel out, minus, and then we'll do the same thing. We'll take this times this one, the 1 over x, and that will give us x plus h times x over that denominator of x. And so what you see happening is the x plus h's are going to cancel, and you're just going to be left with x minus, and then the x's cancel, and it's going to be x minus x plus h. Make sure it's minus that quantity though. So now we have the limit as h approaches 0 of x minus x plus h all over, and then your denominator is h times x plus h, times x. So that's equal to the limit as h approaches 0 of x minus h, because we had to distribute, and then you see the factors cancel, the x and the negative x, and so now we have the limit as h approaches 0 of negative h over h times x plus h times x. So now the h's cancel, and now we know we can get back to our direct substitution. So as h approaches 0, we get negative 1 over x times x plus h. And now we can do our direct substitution. So we're going to do direct substitution. We'll plug in 0, and that'll leave us with negative 1 over x times x plus 0, which is negative 1 over x times x, or x squared. So the derivative of the function 1 over x is equal to negative 1 over x squared. And so that's how you find the derivative of a rational function. And we also can look at some of the homework as well. So let's go ahead and move on to the square root one. Now this has to do with the radical, so it's going to be very similar to what we did in class with limits of radicals. So let's go ahead and get started. The derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's the limit as h approaches 0 of the square root of x plus h, that's f of x plus h, minus the square root of x over h. So just like the limits when we had the radicals, we're going to have to multiply by the conjugate. So we're going to multiply by the square root of x plus h plus the square root of x. And remember, when we multiply by the conjugate, the radicals are going to cancel out. So the limit as h approaches 0, so we'll take this binomial times this one. And the middle term cancels, so you have the square root of x plus h times the square root of x plus h. So that's this. It's just x plus h. And then the middle term cancels, and then you have the square root of x times the square root of x, which is just minus x. And then all over, don't distribute the h, because that's what's going to cancel out. H times that quantity. So you can see the x's will cancel, and you're left with the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. So now the h's cancel, and so one last time, the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Now you can do your direct substitution because you got your h's to cancel, so that's 1 over the square root of x plus 0 plus the square root of x, so that's equal to 1 over square root of x plus square root of x, which is equal to 1 over 2 square root of x. So the derivative of the square root of x is equal to 1 over 2 square roots of x. So very similar to what we did with limits on square roots. You're going to multiply by the conjugate, and once again you're going to see that h value cancel out, which is what you need so that you can do your direct substitution again. So those are the last two examples I wanted to show you from the previous notes. Rational, probably one of the harder ones that we're going to be doing, and then the square root functions. Thank you.